Hello friends, my name is Dhruv Kumar and I'm an MBA student in the Spear School of Business. As a part of the academic project for the Business Intelligence Tools and Technology subject, I have been doing a project called Bike Sharing System under the guidance of Dr. Brian Hammer. He's a professor in the Spear School of Business. So as a part of this presentation, I'll be covering the objective, the introduction, the data preparation part, the issues found in that, the data cleansing, the data direction, and the model building. The reason why I've selected a specific model and what I'm inferring out of them, those things I'll be discussing. And then I'll be discussing the results and the assessment of the model. Then we'll be selecting a specific model. I'll also be discussing that what have been our learnings from this project and how the model has come up against what we expected initially. So I'll also be discussing the lessons learned and the problem solving approach which I have taken into this one. Now coming to the project. Bike sharing system is renting bike process of renting membership and bike return via an automated kiosk system is spread across the various locations of the city. The purpose of this project is to build a predictive model which will predict the number of bikes to be rented in a given hour of the day for a given day, given weather condition, temperature, working day, holiday, etc. Using this model, bike renting company would be able to provide a better service to customer based upon number of expected bikes on the road. The traffic management team would be able to plan it better. For the data preparation, we would be discussing the data access, data consolidation, data cleansing, data transformation, and the data reduction. For data, I have referred to the Kaggle website. This project is a competition organized by the Kaggle. For the data content part, we are having the various attributes in the original data, which are like date, time, season. For example, spring has been mentioned as one, summer two, likewise, holiday, working day, weather conditions, temperature, a temp, which is like a feel like temperature, humidity, casual, that is a number of non-registered bike users, registered is the number of registered bike user, and count is the total number of the rentals for that hour. For the data preparation part, uh, in the consolidation of data, we have got two sets of data from the Kaggle. One is the training data set and one is the test data set. The training data set is the data which would be used for developing the model, while the test data set would be the data which would be used for predicting the value of the count, which is the number of bikes to be rented. These data are in the .csv file format, so no further data consolidation was required. The data cleansing usually requires identification of the missing value, removal of the error data, outlier detection, and the corresponding action, data imputation. Luckily, in this case, there was no missing data or the outliers, but the attribute registered was not present into the test data set. So, and the trial run of the models were indicating that the register is a kind of the most important predictor. So in the test data set, based upon the average of last 2 years hourly data, the registered values were imputed and they have been fed into the test data. We have standardized the attributes like the temperature, a temperature, humidity, etc. using the Excel as a tool. Date, time, and hour have been segregated, and hour window is treated as a new attribute. Now the hour window, the season, the weather, they have been categorized. Moving to the next slide, for the data reduction part, we have two attributes, the casual and the date, which have been removed. And the reason for that was that casual is basically the casual number of riders in the initial. And in the initial model, it comes out that casual is not a required parameter. Its contribution in the model prediction value was very low. So it had, and this data was also not present into the test data set. So it has been removed. Date, since the objective of this project is to do the prediction for the hour slots, so the date was not adding any value. At the same time, all the characteristic of any particular day are getting covered by the season, weather, temperature, holiday, working day, etc. So the date has been removed. So now we are kind of ready with our data. It's a time to go to the model building, and based upon the objective of this project, it's very much clear that we will be needing a predictive modeling technique for this project. So what we'll be doing in this section is we'll be doing some data exploration, then we'll be going on selecting three different modules for the predictive analysis, and then we will be building these models. So for the data exploration, we have taken the average, median, and standard deviation of all the non-categorical data which were present in the source data input, and for doing and this thing we have used the Tableau as a tool. These values are presented into the right side of the screen. In this slide, we are showing some of the trends which the source data was having in terms of their contribution into our target variable, that is the count. So the top plot is indicating the hour slots versus the count, which is indicating that at what hour the bike are used most, and the bottom chart is indicating the uses of bike, that is count versus the season. And this chart is indicating the count versus the weather, and the one which is next to that is indicating the count versus the working day or the holiday. So we can see that if it is not a working day and if it is a holiday, the number of bike rented were relatively very low in comparison to when it is a working day and when it is not a holiday. That indicates that the people primarily use bike for going to their workplace kind of thing. So now we are in the section where we would be working on the building the model. So for the purpose of this project, we have selected three models: the neural network, the regression, and k-nearest neighbor. Why we have selected these models, we will be discussing that into the section which would be coming next. So to start with the neural network, so here we'll be looking at what neural network is and why neural network model. So neural network is actually a non-linear sophisticated modeling technique used for complicated cases where the exact nature of the relationship between the input and output is unknown. As these are printed as a system of interconnected neurons which can compute the value from input and are capable of machine learning as well as the pattern recognition because of their adaptive nature. Coming to the regression model is basically used for creating a relationship between the scalar dependent variable, which is count in our case, and one or more independent variable, which is like working day, season, temperature, etc. in our case. So k-nearest neighbor is a pattern recognition statistical method. A new sample is classified by calculating the distance of the nearest neighbor training case. So for building the model, we have used the IBM SPS modeler as a tool. For creating the model into IBM SPS model, we use the nodes, and the output is the model. So the node which we have used are like the source node. We have used the source node to import the data into SPSS, and then we have used the type node to define the various kinds of data types and their role into the model. Then we have used a partition node. Partition node is used to tell the modeling tool that how much percentage of data need to be used for the training purpose and how much percent of data need to be used for the testing purpose. So this picture is the model presentation of the neural network. In the middle, we can see that this golden nugget is the neural network model, which is created by the IBM SPS. In the similar way, we have this model created for the regression, and then we have the model created for the k nearest neighbor. So now we are having the models created. So we have used these models and the test data set which has been provided to us to do the prediction values. So these three models are actually indicating how we have used them to predict the values. The output, which is actually the count that has been exported into the Excel sheet. So this particular chart is showing the output of the prediction. The rightmost column, which is the number of count, is indicating the number of counts for that particular hour slot. So now that we are done with our modeling, it's a time to discuss the results and the assessment. So in this section, we're discussing the results of each of the models and selecting one model, and we'll be providing the reasons for that particular selection. So for the neural network, we can see that neural network has provided 98.5% accuracy, and as per the neural network, the most effective predictor is the number of registered persons. And if we see the network diagram, it is also indicating the thick lines all connecting to the registered attribute. That is an indication that register is the most important predictor. For the regression, the table in the right top is showing all the correlation coefficients, and the chart in the bottom is again showing that it's a registered, which is the most effective predictor. For the result and assessment, for the k nearest neighbor, the pictures are indicating the predictor space and they are indicating the error log. So now we are the stage where we would be doing the assessment of all these three models, and we would be doing it based upon the R square values and the linear correlation and the graphical comparison between the observed and the predicted values. So the model assessment, we would be using the R square values, and R square is basically a statistical measure which indicate that how well the data fits in a statistical model, and it is done on the scale of 0 to 1. For the regression model, it is 0.958, and for the neural it is 0.985. So coming to the linear correlation exhibited, the purpose of a linear correlation is to determine if there is a correlation between two sets of data. The linear correlation so that the relation between the predicted and the actual values. Higher the correlation, better is the model. It ranges from -1 to 1. So for the neural network, for the training data set, the linear correlation is 0.992, and for the test data set is 0.993, and same for the regression, it's 0.97 and 0.99, and the KNN is having 0.975 and 0.94, which is actually a very good correlation for all three of them. So this section, we'll be doing some graphical comparison between the predicted values and the original values for all the three models. So for the neural network, we can see that the orange line is actually the original values, and the gray line is the values which we have got from the prediction. Gray lines are following the orange line in terms of the pattern, but they are still in a kind of offset in terms of the hours. In this diagram, which is for the regression, it is also showing the similar trend as was shown by the neural network, but this is also offset by few hours. So moving to the next one, which is the KNN, and for the KNN we can see that the predicted values are almost very closely following the original values. Seems like it's a good indication, you know. So moving to the section where we'll be doing the final selection of the model, and my recommendation for the final selection of the model would be the KNN nearest neighbor, and the reason for that would be that KNN is a robust model. It is very effective for the large data set, and in our case it has shown 98% of the linear correlation, and the values predicted by the KNN are very close to the original values which has been given to us. So in this slide, I have done a plot of the output of the KNN against the time. So we can clearly see that during the hours like 8 a.m. in the morning and around 5 and 6 p.m. in the evening, the demand for the bike is the maximum, and during the afternoon hours is kind of moderate. And then before 6 a.m. and after around midnight, kind of the bike demand goes down. This is indicating a the real world scenario, because in the morning and the evening people commute to their workplace, but in the afternoon it's a kind of moderate use, and in the night people take rest. So seems that the prediction done by our model is very much aligned with the real world scenario. So seems like we are on the right path. Now coming to the original version versus the final one, the final form of the predictive model has come up very much as it was expected, and the top influencer, which is the number of registered, is selected by all the three models. So which is also kind of going in the same line. Comparison of the actual values against the predicted values are coming very close, and the accuracy of models are also very high. So way forward, as we know that as no data preparation is perfect, and so as no model is perfect, so going forward my recommendation would be that for now let's use the KNN for predicting the future bike demands. But if the time and the cost permit, let's keep working on the input data and on the model in order to get the best predictive model possible. Solutions which have been learned is that modeling is as much science as it is art, because you need to use a lot of intuitions to find out that what to look, where to look, what to include, what to exclude, and in how we need to uh, manipulate our data or to play around with our data to find the kind of information which we are looking for. Preparation of data is the most crucial part of the entire modeling process, and no data and no model is perfect. So keep trying till you get that golden nugget. Approach to problem solving. The approach which I would suggest would be that to be focused, spend time with the data, make data your friend. The data themselves will give you the hints about the problems which you are looking for. Always look for one more alternate option, and always think that what if. So with that, I'm ending my presentation. Thanks a lot for your time. Thank you.